In the previous tutorial, we looked at setting up waveform sampling. In this tutorial, we'll take a closer look at optimizing sampling. The sample rate that you want to use for waveform channels is set in the Channel Parameters dialog, as shown. But the actual sampling rates for waveform channels depends on your time resolution and ADC rate settings. Here we can see that, based on our current settings, the best rates we can get are only 2/3 of our requested rate for the spike channels. The Resolution tab in the sampling configuration contains a number of options that you can use to optimize these settings and get as close as possible to the sample rates you want. Members of the 1401 family have different capabilities. You would generally select the model that you are using to sample here. Spike2 version 8 no longer supports the 1401 Plus or the original Micro 1401 for sampling, but they are included in case you need to match previous configuration settings. If you replace a 1401 with a more recent model, you may get different waveform and wavemark sampling rates. The new rates will be closer to the requested rates, but if you are halfway through a study, matching the settings of earlier data will be more important. This section of the dialog disables new features so that you can match the original rates. In Spike2 version 8, the default setting is to sample to 64-bit data files, which allow both high timing resolution and long runtimes. If you need to match with files used by older versions of Spike2 or other third-party software, you can set the file output to the old 32-bit format. Times measured by Spike2 are relative to a master clock in the 1401. The microseconds per time unit field sets this clock tick period. If recording to a 64-bit file, you can usually set this to 1, giving a wide choice of sample rates, and no limitations on runtime. If you are recording to the old 32-bit format, you have to balance the desire for timing accuracy against how long you need to sample for. With a 32-bit file, the maximum sample time is just over 2.1 billion ticks of the microseconds per time unit field. The longest runtime field displays the maximum file duration based on the current time units. You can adjust the microseconds per time unit field to give you at least the duration that you need. There is actually a file length limit for 64-bit files, but it is so large that it is of no practical restriction. With 1 microsecond resolution, you could sample to a single data file for 256,000 years. Now we'll look at some of the other settings that can help to optimize sampling to 32-bit data files, and change back to general compatibility to show how changes to these settings can affect sample rates. The Optimize field sets the parameters Spike2 changes to minimize sample rate error. With partial fixed time units, you set the microseconds per time unit, and Spike2 adjusts the time units per ADC convert to minimize the sampling rate errors. With full time units can change, Spike2 generates the best overall settings for your combination of channels. The microseconds per time range fields set the acceptable range of time units. None use manual settings gives you control over both fields. Time units per ADC convert sets the ADC clock interval in the units set by microseconds per time unit. The ADC will convert at field shows the aggregate sample rate in Hertz. This is then split between the waveform channels to get as close as possible to the requested rates. In this mode, click the Suggest button to get values that minimize sample rate errors. Groups places additional restrictions on how Spike2 maps the requested sample rates into achievable sampling patterns. Keep same sample rate groups makes sure that all waveform channels with the same ideal sampling rate have the same actual rate. You will normally use this option. Ignore same sample rate groups gives the smallest sampling rate errors, but channels with the same ideal sampling rates may get actual sampling rates that are different. As shown here, where one of our spike channels gets the requested 25 kHz, but the other gets only just over 8 kHz. Version 3 compatible should only be used if you need to match sampling rates to old files recorded with Spike2 version 3. Burst mode sampling can be useful when you sample more than one waveform or wavemark channel. If you have n waveform and wavemark channels, you may be able to run the Spike2 clock, set by microseconds per time unit, n times slower. This can allow longer sample durations if you sample to a 32-bit file, and you may also be able to achieve sample rates per channel that are n times higher for the same Spike2 clock rate. The disadvantage of burst mode is that waveforms are sampled at times that may fall between Spike2 clock ticks. Each time the ADC is clocked in burst mode, a group of samples is taken. Channels are sampled at precisely the correct interval, but each channel is shifted sideways by up to half a Spike2 clock tick from when it was sampled. In many applications, this will not matter, and the benefits of a better sampling rate may outweigh this. In version 8, where you can have a very small clock tick, this may not matter at all. Burst mode is most effective when you have a large number of waveform and wavemark channels. I hope this tutorial has been useful in showing you how to get the optimum sample rates for your recordings.